Hello students and welcome for engineering mechanics lecture series. Today we will discuss the second slot what we say second lecture on module number 3, force system, equilibrium and friction. Okay, so in previous lecture we have already discussed different types of supports, then different types of loads, how we can convert uniform distributed load into single point load. Okay, so that difference you must understood, because most of the problems which is asked in a university examination will be based on the uniform uh, distribution load or uniform variable loads. Okay, so today we will take three problems. First, which is shown in screen, you can just go through the problem. Determine the tension in chord AB and BC for equilibrium of 20 kg block as shown in figure. So in this figure there are total three forces which is acting. First, that is 20 kg. Second, we can see the tension at point A, so we can say TA also. And second and third one is a tension at point C. So more or less there are three forces which is concentrated or concentrated at point B. So it means that if we have a three forces and which are coplanar and concurrent, so in this case we can go for Lami's theorem. Okay, so before going further we have to make a free body diagram. Okay, we know that how to make a free body diagram. Free body diagram shows the different forces, their locations, and couples and all, etc. So so free body diagram for this problem is look like this. So 20 kg is given. We know that the unit of force is Newton. So we are converting 20 kg into Newton by multiplying 9.81. Now if you compare both the diagrams, the given figure and the free body diagram, the 45-degree angle is shown over here, plus there is a 90-degree angle between line BC and B to it. Okay, so total addition of 45-degree plus 90-degree is 135, and in between the other forces, that force AB and mass, that is 30-degree plus 90-degree, it gives you 120-degree, and remaining angle in between these two tensions like chord AB and chord BC, it will give 105-degree. Okay, so with this simple conversion we can find out the exact forces in chord AB and chord BC. Okay, with the applying Lami's theorem, what we will get, we know that if we consider force AB, it is having a sine ratio with an angle 135-degree. So you can write f of AB divided by sine of 135, which is equal to f of BC divided by sine of 120. And the last one is the 20 kg mass, which is converted in Newton, 20 into 9.81 divided by sine of 105. Okay, so considering the Lami's theorem, we can write these equations and simply we can equate the unknown parameters with the known. So we can equating first these two equations. So 20 into 9.81 divided by sine of 105, which is equal to f of AB divided by sine of 135. So when you solve this equation, you will get force AB, which is equal to 143.6 Newton. Now next, you can use this combination or first equation and last one. Okay, by equating these two equations, you also get the value of f of bc. Okay, which is equal, which is we can find that 175.91 Newton. So whenever any kind of question is given in examination, first of all you need to understand which laws or which type of free body diagram can be created. So create free body diagram, and after that you have to apply the basic laws which we know that. Okay, so I hope this one is a very simple and common exam problem which we can have already solved in a practicals also, in Lam's theorem practical. Okay, so we can move further for next problem. Calculate the support reaction for the beam. Now this problem you might be look like it having a multiple forces, how we can convert these forces into uh, single point force. And again you will might be think like that, or there is a couple, so how we can utilize that couple. Okay, before starting solving any problem, first of all make free body diagram. Okay, so I will give you 2 minutes, you can make a free body diagram. Okay, and after that we will discuss. While making a free body diagram, you will consider the basic supports reaction, as well as you can convert the uniformly distributed load and uniformly variable loads that we have to convert into single point force. So use your pen and paper and try to make a free body diagram. You can pause the video also, and you just try to make the free body diagram. Okay, in between we will discuss the basics. Again, we are recalling the type of support. If there is a hinge or pin type of support, there are two reactions. Actually, it can be occur horizontal component and vertical component. If you have a rolling support, if it is in a horizontal direction, movement is in a horizontal direction, the reaction will be occur vertically. Okay, so it might be help you to making a free body diagram. Okay, I hope roughly you have created the free body diagram. So let us discuss how to make this a problem into simple a free body diagram. So first of all, I just draw a simple AB line, AB A and B, that is a beam AB. Okay, now first let us consider this hinge support. So in hinge support, there will be two forces which is acting over here. So first component is a vertical component, second component is horizontal component. Okay, so you can make a horizontal of A, and you can say vertical of A. So these two components acting as the support is hinged. Now considering the uniformly distributed load. So for uniform distributed load, I just mark the problem points first. Okay. So this one is a A point, this one is a B point, and this one is a C point. Okay. Now, first of all, we need to convert this 20 kilonewton per meter UDL force, uniform distributed load, into single point force. So I hope you have recalled the previous lecture. Uh, we can make this UDL force into single point force by creating its magnitude. How we can calculate the magnitude? W into L. W into L. So 20 kilonewton multiplied by 6, that is 120. So the magnitude of single force is equal to 120 kilonewton. Okay. Now we need to place this single point force in the span of 6 meter only. Okay, because it having a span of 6 meter. So to calculate the distance from A or C, we have an equation. We know that the length from these two sections. So let us say total length is L, and after the conversion of single point, we can place this in L by 2. Okay, so remaining spans is also L by 2. So it means that the magnitude which is calculated is 120 kilonewton, and the length is L by 2, that is a 3 meter. So from point A you can mark a 3 meter point, that is from this point to this is 3 meter. Okay, and you can place a single force in downward direction, and it having a magnitude of 120 kilonewton. Okay, I hope you have understood, and it is very simple to convert the uniform distributed load into single point load. Okay, next one, we have a load of 30 kilonewton. Okay, so that 30 kilonewton you can directly place over at the point C, that is 30 kilonewton. Okay, now anything else which is need to be placed on point C? Yes, there is a couple. There is a couple which is having a value of 40 kilonewton per meter. Sorry, 40 kilonewton meter. So you can directly place the couple at point C. Okay, that is 40 kilonewton meter. Okay, I hope this is easy to understand. Now, next one is remaining force is 45 kilonewton per Newton meter. It should be Newton per meter. Okay, so it we need to convert this total force, that is uniform variable load. This kind of load is uniform variable load. Now how we can place and convert the uniform variable load? So we have seen uniformly distributed load. So it means that it also having some equations. So based on that we can convert the uh, uniformly variable load into single point load. Just recall previous lecture. In previous lecture we have seen that if you have a uniform variable load like this, you can convert that load having a span of length L and the magnitude is W kg Newton per meter. So we can convert this into 1/2 to calculate the force magnitude. 1/2 into W into L. So based on this you can find out the magnitude. Okay, so 45 multiplied by 4 divided by 2. So we can get 180 divided by 2 is 90 kilonewton meter per meter. So we get what you can say, we get the magnitude is 90. Now what about the length? The length which can be placed from left side, it is 2/3 of L, 2/3 of L, and from right side it's 1/3 of L. It is 1/3 of L. So you can convert the length and you can apply. So what I can say, for 2/3 of length from C side, from point C, and 1/3 length from point B. Okay, so you can find out the 2/3 length, that is 2 multiplied by 4 divided by 3. So 8 divided by 3 will be the distance from C, and 4 divided by 3 will be the distance from B to C side. B to C side. So we can place this force in this location. Okay, the from distance from B side will be 4 by 3 meter, 4 by 3 meter, and the distance from C to that single point load is 8 by 3 meter. Okay, with the help of calci you can directly find out the exact values. One more thing is remaining, that is support at point B. That is which type of support it is? Rolling type. Okay, so for rolling type we need only one reaction, that is RB. That is RB. Okay, so I hope you have seen all the type of supports and forces in this free body diagram. So once again we can recall. First, identify the different type of supports. In this problem there are two types of support is given at point A. It is hinge type, or you can say pen type, and at point B it is rolling type. Okay. Oh, now next to the different type of forces which is acting and their directions. Now if you see the distributed loads, it might be a first one, that is uniform distributed load. I will use short form for this is UDL, and second one is uniform variable load. You can use shortcut UVL. So in UDL, the direction is in a downward direction. So we have converted the total spam force acting at 6 meter into single point force, that is 120 kilonewton. Okay, and its location from point A is L by 2. So we have located that one. At point C, there are two forces is going to be acted. First one is a couple, that is 40 kilonewton meter, and second one is a vertical downward force of 30 kilonewton. Okay, at point B, only one force is there, that is a reaction which is occurred due to rolling support RB, which is in opposite direction of the force, so it is vertical upward. Now remaining is U will load, which we have converted into single point by using equation 1 half W into L, and its length or its position from point C, it can be located at 2/3 of L, or from point B it is located at 1/3 of L. Okay, so I'm rearranging this one in a proper manner. So after rearranging all the things, what we get will get the all the positions of all forces from point A, positions of all forces from point A and their respective magnitudes. Okay, I hope it is very clear about you. It is very clear to you how we can taking a distance from point A only. As we know the as we know, for equilibrium we have a three conditions for equilibrium of beams. First one, summation of f of x is equal to 0, summation of f of y is equal to 0, and third and last is summation of all moments is equal to 0. So based on these three criteria, or you can say conditions, we can find out the unknown forces, unknown values of v horizontal component at point A, vertical component at point A, and the reaction due to rolling support at point B. Okay, so first just identify the basic three laws I have just three conditions I have just mentioned. Let us apply first condition. Okay, so first condition, by considering the ABD diagram of AB and taking a moment at point A. So taking a moment at point A, first force nearer to AB is 120 degree, which is in downward, 120 kilonewton, which is in a downward direction, having a length 3 meter. So minus 120 multiplied by 3. Got it? Second force 30 kilonewton at a distance of 6 meter. Again, it is in a downward direction at right side. So it is also negative in a direction. So minus 30 into 6. Now there is a couple is acting in a clockwise direction, and right side clockwise direction is negative, anti-clockwise direction is positive. So whenever you have a couple, you can directly use that value. You need not to create the distance, multiply with the distance. So you can directly use 40 kilonewton meter, that is, as it is in a clockwise direction, minus 40. Next force is applied, that we have converted UVL in single point, that is 90 newton, 90 kilonewton into the distance, that is 8.67. And last one is remaining the reaction at point B. So RB into 10 which is and all equals to be 0. It means that moment of at point A is equal to 0. So in this equation, only one is unknown, that is RB. So we are easy to calculate the value of RB. After the calculation, we get RB is equal to 136.03 kilonewton as it is positive. So it's in a upward direction. Now next, you can consider summation of f of x and summation of f of y. So if you consider f of x, there is only one force which is acting in x direction, that is h of a. As summation of f of x is equal to 0, hence the h of a is equal to 0, as there will be no another force which is acting in a horizontal direction. Now we can applying third condition, summation of f of y is equal to 0. So we can get VA, that is vertical component acting due to hinge point support. Okay, so VA upward direction positive, 120 kilonewton in downward direction minus, 30 kilonewton acting at downward direction minus. Here we are not using couple because it is only we are considering the forces. Okay, so we are not considering 40 kilonewton per kilonewton meter couple in this calculation. Another force which is a UVL we have converted into 1 point, that is 90 kilonewton. It is also in a downward direction, so it is negative. RB in a positive direction, which we have calculated previously, that is 136.03 kilonewton. So addition of all, by solving this equation, you get a vertical component at point A is equal to 103.97 kilonewton, as it is positive, so it is in a upward direction. Okay, so once again you can just recall the total process. First, we need to find out the free body diagram. We have to convert the loads like UVL and UDL into single point load, identify the location of these loads. Then next, based on the supports, you can find out the first reactions, which kind of reactions is occurring at particular point. Okay, and afterward you can apply these three conditions of equilibrium, that is summation of all moments is equal to 0, summation of all forces in horizontal direction, that is f of x is equal to 0, summation of all vertical forces, that you can say f of y is equal to 0. By using simply three conditions, you can find out the all unknowns given in the problem. Okay, I hope you have understood the basic process how we can solve the support reaction of beams. We'll take one more problem, but for this I will give you 2 to 3 minutes to draw a free body diagram. Afterward, I will give you 5 minutes to calculate the unknown values. Okay, so here on your screen, the next problem. Okay, now try to draw. I will give you 2 minutes. Try to draw a free body diagram for this. Carefully observe the support reactions and the load given. I hope you have done. Uh, in this problem, might be few student is quite confused about the load given, that is mixing, or you can say combination of UDL as well as UVL. Okay, let's first of all discuss on that. From this point to this totally it is UDL, uniform distributed load of 20 kilonewton per meter. And about the UVL, it is acting from this side to this side. So the value of this is nothing but 50 minus 20. 50 minus 20. So which is equal to 30. Which is equal to 30. Okay. So you can now try to draw a free body diagram. Okay, let us start. First of all, draw line AB. Everybody has already drawn, I hope so. There are 3 points. You can see point E. This one is a point B. I can just mark as a point C. This point as a C. Okay. The condition is a overhang condition. First of all, it is not fixed side. Okay. It is overhang condition. At point A, it is a hinge support. So I'm changing the color. Hmm. So at point A, as a hinge, so we have a two different uh, components. That is a horizontal component at point A, vertical component at point A. Okay, I hope that much you have done already. At point B, there is some angle for rolling support is given. So it is nothing but it is about to 30-degree with the horizontal. Okay, so I'm just making a vertical line. From that I have to take the angle. So as we know that this angle is a 30-degree. So what is the remaining angle? So its remaining angle is nothing but 60-degree. 60-degree. So now your reaction is acting at 60-degree. Okay. So you can say RB. I hope you have understood. You can simply say it is a perpendicular line over here, perpendicular line over here. So you can minus the 90 minus 30, which you will get directly 60-degree. Okay, now next one. At this point your distributed load is acting for 6 meter span. Okay, total span is a 6 meter. Now first convert, let take let us consider first force, that is 20 kilonewton, 20 kilonewton, which is uniformly distributed load, that is UDL load. For UDL, what is our equation? First, to calculate the magnitude of force, you can say W into L. W into L, how much it is? 20 into 6, that is 120. 120 kilo Newton. About the length, which is L by 2, let us say this point is a P point and this point is a Q point. Okay, so from P and Q you have to, this one is a Q point. From P to Q we have a 6 meter span. So in this 6 meter span we have to properly arrange this distributed load. So for 20 kilometer only we are considering this area. Okay, so we have converted considering, not like a considering, it's a combination of UL and UDL. So we are taking this area as we know that it's uniformly distributed load 20 kilonewton. We can convert this 20 kilonewton into uh, single point force, that is 120 kilonewton. About the distance 6 L by 2 from P, point P or Q, from both side it is same. So at 3 meter, L by 2 is a 3 meter. So at 3 meter you can apply this converted force of 120 kilonewton. At what distance? It's a 3 meter. From here to here it's 3 meter. Now what about the remaining force? How we can find out the value or magnitude for remaining force? It's very easy to find out the value for remaining force by considering this force is UVL, uniform variable load, and convert this force into single point force by using same process. Using same process. Okay, so let us start. For UVL, the magnitude is remaining 30 kilonewton. So the value of W to convert this is 30 kilonewton meter. So find out the single force value, that is 1 half W into L. So 1 half W is 50 into L is 60. So total is 300 divided by 2 is 150. So magnitude of this force is 150 kilonewton. Kilonewton. Now next, what about the location? For location, we know that from starting point it is 2/3 by L, 2/3 by L, and from end point it is 1/3 by L, 1/3 by L. So simply you can calculate these values. So I'm calculating 1/3 by L, that is 6 divided by 3 is 2 meter. From point Q, I'm putting 3 meter, sorry, 2 meter, it's 2 meter, and placing this force, that is 150 kilo Newton. Okay, now everything we have sorted, only one force is remaining, that is 80 kilonewton. We can place 80 kilonewton at point C. This is 80 kilonewton. So you can find out the locations of all forces from point A. Because we have to take moment, we have to apply three conditions, and based on that you can find out the value of RB. Okay, is that clear to everyone? I hope it is quite easy to understand the total process which we have done right now. I'm just simplifying this total free body diagram. Okay, so you will get the exact values from point A. Now I will give you 2 minutes to find out the basic reactions, or you can say uh, the most important. We can apply three conditions: summation of moments at point A is equal to 0, summation of all the forces, that is f of x is equal to 0, summation of all the vertical forces, that is f of y is equal to 0. Okay, I will give you 2 minutes. You can calculate whichever you are going to be understood. Okay, just start it. Okay. So we can start the solution. So first of all, you need to consider obviously the free body diagram for point AB of AB. Taking moment at point A, we have consider all vertical forces as, and for RB we have to consider a vertical component of RB, that is RB into sine of 60 multiplied by the distance which is placed as a 10 meter. It is in upward direction, so it is positive. Second force is UVL, which we have calculated, that is 120 kilonewton into the distance of uh, into the distance of mm, 5 plus 2 plus 3, that is 5 meter. Okay, in previously we have done a small mistake, that is 150 30 into 6, that is 180 divided by 2, it's 90 kilonewton. That is my calculation mistake. Just recorrect it. Now next one, that UV force which we have already calculated, which is placed as at a 3 6 meter from point A, acting in a downward direction, so it's negative. And last one remaining, the force acting at point C, uh, which is we have mentioned in a previous free body diagram, that is again it is acting in a downward direction, so 80 multiplied by the distance is 13 meter, and equating all the summation with respect to 0, so that is nothing but moment at point A is equal to 0. So in this equation only one parameter is unknown, that is RB. So you can simply solve this equation and find out the value of RB, which we have calculated is 251.73 kilonewton. Now next, to calculate the horizontal and vertical component values, as we know that there are two forces acting, and one force is acting in a vertical, that one is a horizontal component of RB. Okay, let us consider that. So HA, horizontal component, is acting in inward direction towards A, so it's negative. So that is 251.73 cos of 60. Okay, so that is directly given the value of HA, horizontal component, due to hinge point reaction at point A. Next one, next is remaining condition, that summation of f of y is equal to 0. So here also we have one unknown, that is a vertical component occurred because of hinge point at point A, VA, which is in upward direction, so it's positive. 120 kilonewton, that single point force uh, calculated due to UDL, that is in downward direction, so minus 120. 90 kilonewton force, which is single point force of UVL, upper portion of the given uh, distributed load, it is also acting in a downward direction, so it's negative. Then vertical component of reaction AB, sorry, reaction B, which is occurred due to rolling contact support, that is 251.73 sin of 60, and last force is 80 kilonewton, which is acting in a downward direction, so it is negative. So by calculating this equation, we can find out the value of VA is equal to 72 kilonewton, which is acting in upward direction. I hope you have understood how to convert the combination of UDL and UVL in single points, because it creates two single points forces, one for UDL and second for UVL, and how to find out its location. Okay, now there is another example. You have to calculate, first of all, free body diagram. Okay, one condition is given. In the reaction support A is 0, if the reaction support A is 0, we have to calculate two values. First of all, reaction at point B, that is rolling support reaction, and unknown force of load P. Okay, just take a 2 minute and draw a free body diagram. Okay, done. There is no that much complications as per the previous problem. So let us start to make a free body diagram. First of all, draw a total span from point A to point F. Okay, as we know that the condition is given, all support reaction at point A is equal to 0. So we are not considering any support reaction at point A. We are placing first load, that is 10 kilonewton, then placing the couple of 20 kilonewton meter, then placing the reaction at point B, that we can say RB, then at point E we are placing force P. Okay, and you have to convert UVL into single point load. So for UVL, the magnitude will be 1/2 into W into L, that is 24 into total distance of span 3 meter divided by 2, which can be occur 24 multiplied by 3, 72 divided by 2, that is 36 36 kilonewton, which we can find out 36 kilonewton. Now what about the distance from B point? If we take a distance, that will be 1/3 of L. So it is very simple to calculate. 3 divided by 3 is 1 meter. So at 1 meter you can place this force, that is 36 kilonewton at a span of 1 meter from point B. Sorry, 1 meter at point from point B. Okay, I'm simply arranging this. In this free body diagram, I have shown both three actions, that is H and a vertical and horizontal component at point A to just for simplicity understanding purpose. Uh, by considering the given condition, we have to solve, or you can weigh, we have to calculate the unknown forces RB and P. So first of all, taking all vertical components is equal to 0, that is summation of f of y is equal to 0. So first vertical component of A, which is as per the given condition, it is 0, so you can directly neglect it. RB, which is unknown, 10 kilonewton, which is in a downward direction, that is negative. 36 kilonewton, that is uval force, it is in a downward direction, so it's negative. P is acting in downward direction, so it is also negative. So from this equation you will get the value, or a simple equation, because there are two unknowns RB and P. So by simplifying this equation we will get RB minus P is equal to 46. Okay, now next one, as we know that f of x is equal to summation of f of x is equal to 0. Okay, so you can use that condition, you can write down that condition also in middle or at the end also. Now next one, we are considering all the moments at point A is equal to 0. So taking moments at point A, first RB into distance, that RB into 6 minus first force 10 kilonewton, 10 into 2, it is also in downward direction, so negative. So and 20 kilonewton, that is a couple which is also rotate acting in a clockwise direction, so it's minus. Then single point load of uval, that is 36, multiply the total distance from A is 5 meter, then P into the distance, that is 7 meter. So these are the forces which can be considered for moment. So based on rearranging this equation, we will get another equation, as we have two unknowns. Okay, 6 RB minus 7 P is equal to 220. Now we have a two equations, equation 1 and equation 2. We can solve, as two equations having two unknowns, we can easily solve this equations by simply putting, you can put RB is equal to 46 plus P by from equation number 1. Okay, and simplify and calculate the value of P. Okay, or you can direct sorry, in the form of RB you can convert in the form of P, or P you can convert in the form of RB, whichever you are able to understood, or which one is simply for you, you can calculate. Okay, By solving these equation 1 and 2, we will get Rb is equal to 102 kilonewton and P is equal to 56 kilonewton. Okay. Is there any difficulty so far to calculating these values and reactions at point uh, A, at point C, then placing the UVL load into single point load, and reaction at point B, and the unknown load at point E. So before solving any problem, you need to draw free body diagram, okay, which will give you the exact idea what is the unknown, which things need to be calculated, and what to be find. Okay, I hope these problems are quite easy to understand, and similar type of problems will be held in your assignments as well as in university question paper. The similar kind of problems will be asked. So again, I will request you go through the total process to find out the values of unknown, okay, by satisfying the condition of equilibrium, that is summation of f of x, summation of f of y, and summation of all moments is equal to 0. Okay, also I request all of you to revisit the different type of supports, different type of loads, and conversion of distributed load, that is UVL and UDL, into single point and its location. Okay, so it will help you easy to calculate all the unknown parameters and the reactions. Okay, I hope these three problems are quite understandable properly by everyone. If you have any doubt, you can uh, personally ask me. And one more thing, I'm sending attendance link in this in chat box. Sorry, chat box not. It in a description, so you can mark your attendance for today's lecture. Thank you. Thank you very much. If you have a problem or any doubt, you can personally contact me. Thank you. Thank you very much.